Hello, welcome back. In this segment, we're going to look at some more data types in the C language. Up until now, we've been using int and double, and there are lots of different data types in the C language, and you, as you now are comfortable working with the two data types that are the integer type and the floating point type, we have some more that mostly allow you to choose one that's an appropriate size for the data that you have. So if your numbers are all going to be very small, then you don't need to use an int data type. Maybe you could use a char data type, for example, so that it takes up less space. The concepts that we've been using, including the mixed type arithmetic, all apply to these new data types. So there are no real new concepts in this segment. There are only new data types, new percent sequences for scanf and printf, and I guess it is a concept, if you want to call it that, that you have to now choose among more data types to get the appropriate one for your particular variables.
We could point out here that this used to be a critical part of computer programming when RAM memory was very expensive and programmers were required to keep the size of their variables or the use of RAM as small as possible so that the program would run faster on those machines that had really very limited memory resources. So in modern programming, you would rarely, if ever, worry about a few bytes of memory. We would only try to choose the smallest possible data type if we had large numbers of variables of that data type or arrays of that data type, and we would then be concerned that the program would become bloated unnecessarily if we chose a data type that was too large. So here is a table of data types in C, and the first two are float and double. We've been using double up till now, and one double variable requires 8 bytes of memory. It has this huge range of values that we can store in it. 2.2 times 10 to the minus 308 up to 1.8 times 10 to the positive 308. So the reason we call these floating point is because the decimal point can move around. In the case of a double variable, 308 places to the left or 308 places to the right. Double used to stand for double precision. Well, it still does, but we don't call it double precision anymore, just double. And it's double that of a float. So a float variable, which you may see in your C programming textbooks, is the 4-byte floating data type. It takes 4 bytes of space to store one of these, and the range is much more limited. The interesting part about float and double is that the float data type has less accuracy than the double data type. And we'll see on the next slide what the difference in the accuracy is. Let's look at the data types that are used to store integer variables now. The first thing that you might notice is that the data type that we've been using, int, is not on this table. And the reason for that is that an int in different C compilers means different things. So an int may be 2 bytes of space, or it may be 4 bytes of space. So what we've been using in our Microsoft compiler is a long int, and if you just use int, then it defaults in this compiler to a long int, and that's 4 bytes of space. So the range of values we can put in our long int variables is negative 2.1 billion to positive 2.1 billion, and that's approximations. So a number that goes over 2 billion, you're going to have to worry about whether it will fit in your int variable. A short int, some compilers, if you just use the keyword int, will use a short int. and this stores in 2 bytes of space, and the range is severely smaller than the long int. In fact, it's from negative 32,000 to positive 32,000 approximately. There's exact numbers there on the slide. A smaller integer data type is the character data type. We'll say this char, or you can say char if you want to. A character variable also stores a small integer number, but it takes 1 byte of space only. This is the smallest data type in C. The char variable stores the range negative 128 to positive 127. You get one more negative value than positive value, and you probably don't know why yet. Don't worry about that. That's an internal representation issue that we're not going to look at. Now, what is this unsigned modifier here? Unsigned means that if you want to use all of the bits that you have for data, you can do that, but at the expense of having any negative values. So if you declare an unsigned char, an unsigned short int, or an unsigned long int, the smallest value you can put in there is 0, and then you have more positive values than that you can store in that variable. For example, an unsigned char has the range 0 to 255, while a char has the range negative 128 to 127. So we have an issue there with whether you want to only have positive numbers, then you can have more of them, and you do that by using the modifier unsigned on your data types. Okay, here's another table that talks about those data types in C, and for input and output you will need some new %f sequences, or these format specifiers in printf and scanf. So if you're using a float variable, you can use %f, and your range of accuracy in a float is 6 or 7 places, and that doesn't matter where the decimal point is. So you could have a whole bunch of zeros after the decimal point and then 6 or 7 places of accuracy. With a double, you get twice as many places of accuracy, or double precision, and you have 15 or 16 places of accuracy. And in scanf and printf we've been using %lf for outputting and inputting data of type double. So the integer data types, the characters, the short ints and long ints. Let's look at character first, or char. An unsigned char, you can use %u or %c. If you use %u, you want to talk about the value, the numeric value that's in that variable, and if you use %c, you want to input or output the character equivalent of that number. So all characters that you can input and output in Java, in C, are really just numeric values, and the printf and scanf can treat them as numeric values or as character values. So for example, the number 65 in a character variable might either be the number 65 or the character capital A. I hope I got that one right. I haven't memorized the ASCII code for each of the characters. Each character has its own unique numeric value, and it's called the ASCII code. An unsigned short int is not used for storing characters, only small integer numbers, and you have the range there 0 to 65,000, and we're going to use %u for printf and scanf, and for short int %i. Similarly for long ints, %u and %i, and you have the range of values there.
Well, here's a summary of some of the things we looked at in this segment. That we have, first of all, the char data type. This is the smallest data type in the C language, and it has room for 1 byte of data. the number that you keep in a char variable may represent the ASCII code of a character. So that's why it's called char. It's still going to be an integer in there. There's no decimal point, and it's going to be a small number. And that might be a numeric that you're storing or the ASCII code of a character. The choice of data type depends on whether you need character, real data, or integer data, and how large the values might be that you're computing with. That was much more important when RAM memory was very, very expensive. You had to try always to get the smallest one. It's somewhat less important now. There is an unsigned modifier for some data types, for the integer data types in particular, that allow you to use that variable for positive values only. So it moves the range of values from where 0 is in the center over to where you have only positive values, and that can be useful if you know you only have positive values and you don't want any negatives. And again, that one was somewhat more important when RAM was very expensive and all decisions were based on that particular cost. Printf and scanf are very strict about the data types that you're expecting, and it's a very common error for people to get these percent sequences wrong in the printf scanfs. So when you run your program, if the result is not correct, sometimes you've done all of the code correctly and then just output the answer incorrectly because you didn't match the percent sequence to the data type. So you have to watch out for that. This is another good reason to be using the debugger all the time. Don't just look at the output from the program. Make sure that you can see everything that the program is doing. And this last one is one that is my least favorite issue in this area. There have been lots of different versions of the C language since it was written around 1972, and the data types also have changed. So the data types that we've looked at are the ones that are available in all C compilers, and some C compilers will have several more data types, things that are a little bit unusual like double double and long long, and things that were added to kind of make their C compiler a little bit different from the others, or in some ways better than the others. So when you become a professional C programmer, this is one of the things you would have to do. Find out all of the data types that are available in your particular C language and make sure that you're using them to their best advantage. That's all for this time. I'll see you in the next segment.